Welcome to the channel Knowledge Star, Continuous Knowledge Excellence. My name is Nisha Masroor. In this video, we will get to know about detection of ovarian cancer biomarker. Now, our expert Professor Himadri Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Teledicon Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics and biophysics. We'll explain you in detail about this topic. So, to get complete information, watch full video without skip.
Example in this is again related to the cancer biomarker. In this case, now ovarian cancer biomarker. Now, the presence of ovarian cancer or the onset of ovarian cancer increases the concentration of platelet-derived growth factor significantly, and this can be used as an indicator of the early stage diagnosis and maybe effective treatment of this cancer. So, can we do a detection mechanism or form a platform, colorimetric platform for detection of PDGF at low concentration? Because in the early stage of diagnosis, the concentration of this is not very high. Progressively increases, but initially it is small. Concentration is small, but more than the normal. So it should be able to, one should be able to detect it. That is the challenge. Okay. Again, our gold nanoparticle is handy in the process. Same behavior. You will see gold nanoparticle transmission electron microscope pictures here and SAM picture here. UV visual spectroscopy 520 nanometers, signature wavelength. The XRD crystalline properties of the nanoparticles, not very important for this. This is the assay description. So the process is very simple. What is done is you take the gold nanoparticles here, this portion that we have just synthesized. Now with the gold nanoparticles, you add aptamers to it. Aptamers are oligonucleotides. They do a wonderful job of bridging biomolecules. It can join to gold nanoparticle surface. Also, it can join with PDGF, which is a protein. Okay, aptamers bind wonderfully to proteins. You add aptamer to it and then increase the ionic strength slightly. Then you'll get a well-dispersed gold nanoparticle where aptamer is sitting on its surface. Same thing, but now we add also this protein, the analyte protein, PDGF. Rest is same. Again, you add sodium chloride. Sodium chloride is added just to prevent aggressive clustering of the particles. Okay, this screens the electrostatic interactions and particles do not aggressively coagulate and precipitate out of the dispersion. That is the reason sodium chloride is added.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
So this controls the aggregation process. So you add NaCl and wait for its file, and you will see that aggregates do get formed. And the remarkable thing is the color of the dispersion, which was wine colored earlier, becomes colorless here. That's because on the surface of the gold nanoparticle, the PDGF gets coated extensively, changing its surface property and the interface drastically. That creates problem with the color, or the color is completely, the material is completely decolorized. The sample has no color after that, at least in the visible region of the spectrum. So now this is the EV visual spectra of this one. Same thing that we have been saying. You have the gold nanoparticle here, PGDF added to different concentration of this. And then you see their spectral behavior is completely changed. And if you just want to measure the concentration of PGDF at a particular concentration 525 signature absorption wavelength, you can have an absorption versus PGDF concentration graph, which will serve as a calibration curve. You can find out the concentration of the unknown sample from there. But what is important for our workshop is, as you increase the concentration, you see that the coloration changes. 10 microgram per ml, 1 microgram per ml, 0.1 microgram per ml, 0.01 microgram per ml. See, at higher concentration, it becomes colorless here. It is intense color. It's slowly losing color, become dim, finally become colorless at higher concentration. Only the base molecule, the heptamer, when you add on the surface, it looks like this, is very much like this one. Interfering molecule like urea, if you add to it, no change in color. So it's not detecting a urea. It's only detecting PDGF, which we wanted. So this is now quantitatively plotted here. With the heptamer, the sensitivity is so high, absorbance is so high. With urea, it's less. With PGDF 0.1 microgram per ml concentration, this is the absorbance value. And correspondingly, the EV visible spectra will be like this. It's more or less same thing what we had seen earlier. Heptamer and gold nanoparticle, green one. With urea, it is the red. And with the PGDF, it is the blue one. And notice that the additional, the appearance of the additional peak in the visual spectra close to about 700 nanometer is a signature of this PDF. Okay, so PDGF actually has two signature peaks. One is 520 that was coming from the core, and the additional higher peak that you will see close to about 700 nanometer is the signature of that protein. So compared to the control, sample will look like this, much dim in color. So this is a very interesting example of how it can be detected by looking at the color of the sample, colorimetric detection.
I hope you like this video. Here, I would like to give you an important information that Nanoscience and Technology Consortium or NSTC organize the nanotechnology workshops on very interesting topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of, like mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. So that's all. If you want to see these type of videos, then please do comment. We will definitely reach out to you. Subscribe to the channel Knowledge Star and hit the bell icon to never miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.